So radians are another way to measure angles. So far in your math career, you've probably only ever used degrees, but radians are actually more universal and a little bit easier to explain. There's no magic reason why 360 degrees is a circle. It's just divisible by a lot of numbers, and it takes about 360 days to go around the sun. And so that it was just kind of easy to assume that. But radians actually make sense because the ratio between the circumference and the radius of a circle, a circumference of a circle is 2 pi times the radius. The radius is this right here, half of the diameter. And so if we're going all the way around the circle, that's how far we're going. We're going 2 pi times the radius, and we call that 2 pi radians. So all the way around the circle is 2 pi. We always start at 0, but this ends up being 2 pi, just like 0 and 360 degrees are in the same position. So from there, we can kind of say, well, then halfway across the circle is going to be pi. Halfway between 0 and pi is going to be pi halves. And halfway between pi and 2 pi is going to be 3 pi halves. We leave improper fractions because they're easier to work with, but we do reduce fractions if we can. So let's look at these orange ticks halfway between those. So notice that what we're doing here is we're splitting pi, we're splitting the top half of the pi into 4 equal parts. 1, 2, 3, 4. So because we're doing that, we can call these, and I'm going to erase those so that we can draw other things. This then would be pi fourths, and this would be 3 pi fourths. And then as we go around, so here's 1/4, 2/4, 3/4, 4/4 is going to be pi, 5/4. 6/4 is 3 pi halves, but we reduce that to 6/4, or from 6/4 to 3 pi halves, and then 7/4. So that's how we figure out those fourths. They're basically like 45-degree angles, but we call them pi over 4. So 45 degrees and pi over 4, they're the same measure, but pi over 4 is a little more universal and has its roots in mathematics. Looking at the red ticks, so here we are splitting the circle into 6. That was terrible. This top half of the circle into 1, 2, 3, 4, 5, 6 pieces. So when we're labeling these, we know this is going to be pi over 6. This one is going to be 2 pi over 6, but 2 divided by 6 is 1/3, so we can just call this pi thirds. All the way around we have this pi halves. We can also call 3 pi sixths, but 3 pi sixths is 3 over 6 is 1/2, so it ends up being the same. So 1, 2, 3, 4, here's our fourth one. That's going to be 4 pi sixths, which is the same as 2 pi thirds. And then here's our fifth one, 5 pi sixths, does not reduce. 6 pi sixths reduces to 1. 7 pi sixths does not reduce. 8 pi sixths is the same as 4 pi thirds. 9 pi sixths is the same as 3 pi halves. 10 pi sixths we can reduce to 5 pi thirds. And finally 11 pi sixths. So as long as you're confident in how to count to 11, really, and then how to figure out whether it reduces or not, that's the gist of how radians work and how we can measure angles using radians.